going to explore shorts and opens with regard to parallel circuits. It's similar to shorts and opens in series, but the effects of what happens in the circuit is just a little bit different. For example, when we have a short, it means that there's a lower than normal resistance. For example, instead of this being 10 ohms, which is its rated value, it could be dropping down to 7, 5, 4, so forth. It goes way down because it's in the process of shorting out. It's losing its resistance until it gets to what we call a dead short, which is approximately zero resistance. But that's the same as just taking a wire jumping and going from this part of the resistor over to here and taking it completely out of there. The problem with shorts in a parallel circuit is they already begin to cause the total amount of current, both in the branch and the total amount of current, to increase. So if the resistance is going down according to this Ohm's law representation, it means that there's going to be a maximum or an increase in the current, the total amount of current for the circuit and the total amount of current going through this branch. Hopefully there is a fuse. I'm going to put a fuse in here that will allow this to protect the rest of the power supply and the rest of the circuit by blowing it, by allowing it to just open and remove all of the current to the entire circuit. So a dead short's normally, when they turn the circuit on, if it's got a dead short, that fuse has to blow, or there's something wrong in the current, the overload load protection device. Okay, in the case of a dead short, that's what it's going to do. Lower than normal, it may come on for a while. Hopefully the fuse will warm up and it will break that time before any other damage could happen to the rest of the circuit or the power supply. But there is a jump in the current when you do have shorts occurring. Dead short, really bad shorts. It could be just lower than normal resistance, could be just a little bit higher than normal current going through that particular part of the circuit. In the case of opens, what the opens are just exactly the opposite of the shorts. An open circuit works like this. It really means that the circuit resistance, or the device resistance, is higher than normal. What this means is that instead of this being 10 ohms, it's increasing to 12, 15, it could be 20, 30 ohms and so forth, until it begins to get the current so low, because this is what's happening with it, the resistance is increasing, which means that the total amount of current is also decreasing, because it's an inverse relationship. Okay, increase in resistance, a decrease in the total amount of current, as well as a decrease in that branch. Now usually when this is occurring, the other branches aren't affected. As long as the power supply is in good condition, all of the series elements are in place, fuse is working, the other branch current should be just fine, as long as this particular resistor is increasing in its internal resistance. Its branch current is going to go down, but it doesn't place a load on the total amount of the power supply feeding all of the branch currents. In the case of what we have is a complete open, this pretty much is what we're going to call infinite resistance, and it refers to resistance that's so high that it can hardly even be measured. In that particular case, all of the rest of the circuit should be functioning perfectly, or it's designed to, and this particular branch, or this one here that has the complete open, is simply off the line. It's one of the handy things about having branch systems on a parallel network, is that if one of them goes open, it just simply can be taken out, replaced, and it doesn't affect the other loads on that circuit. The total amount of current then is going to decrease anytime these two are opening or in the process of opening or become complete open.